presentar Jacob Keizer, que es investigador del CESAN en la Universidad de Aveiro. Nos va a hablar de, bueno, de la evaluación del riesgo de erosión y de la mitigación.
Okay. Good morning, everybody. I'm always a little bit in doubt whether to speak Portuñol or English, but at the end of the day, I think my English is better and we have translators. So, that's okay. So first of all, to thank Christina for organizing this, of course, and Alvaro for inviting me to go to talk a little bit about a specific part of the project, which is assessing post-fire erosion risk and its mitigation. It was already discussed a little bit, but anyway, I'll go over it again from a perspective of our research team from the University of Aveiro. So in terms of content, I'm going to talk about why assessing soil erosion risk following fire. This is a little bit a recap of what has already been said, but I would like to structure it a little bit more. Then talk about how to assess soil erosion risk following wildfires. Then why assessing, again, but part 2. And then some take-home messages, let's say the main points of perspective. So starting, why assessing soil erosion risk following wildfires? Well, this is very easy to explain through this diagram. You see here the occurrence of a wildfire, which affects and reduces the vegetation cover, the cover of the litter layer, and also affects soil properties. And with time, those properties of the vegetation, litter layer, they recover somehow. But during that period of recovery, the so-called window of disturbance, we can have a strong increase in runoff and erosion. And then with time, it returns again to the baseline levels, the background levels, not necessarily erosion zero, okay? So just to give you an idea how this can look like, this is an extreme case from the United States, I've shown it many times, but anyway, if it's okay, you can see here what can happen after the fire. This is in the United States where everything is bigger, as we always say, but anyway, you can see big stones running through the street. It's good nobody had a car parked, otherwise it would have been a big drama for the insurance companies. Okay, so this is an example of what can happen in very extreme cases. So in this case, just to draw your attention to a few things. This video was taken, where's the star on the little map? And the first thing to say is that the area that was burned was not very big, was only 80 hectares. So this is not a very big area when we're talking about thousands of hectares in some cases. What happened? The thing that happened was that there was an extreme rainfall event with 115 millimeter in 26 hours. So I hope you have an idea, but this is like something like 115 liters per meter square in 1 day. So that's really a lot of water. And that's the key to erosion risk, the fact that it rains and can rain a lot. Okay. Now to understand why this happens, of course, what we see in the street, the stones and the soil, that comes from somewhere. And if you see this picture, which is a relatively rare picture, you can see basically runoff occurring everywhere. Yeah. And so it goes from the hill slopes to the stream in the bottom, and from there it goes out. And with it, it takes sediments, in many cases also ashes. So this is actually what happens. What you see in the catchment, that is what happens on the slopes. So basically, we saw the picture, and then comes a video, what this means in terms of a response. On the side. So just for you to be aware that this is also very small catchment, 40 hectares, and you can see the amount of ashes and charcoal which are being transported out of the area. And it goes on the road. We actually had to remove our car. It was on the forest road. This was the second rainfall event after the fire. And you get such a very violent response, which of course not only is risky in terms of flood risk, but also transport and exports nutrients and so forth. So in resume, what can happen after a fire in terms of soil erosion risk. We have the risk of losing soils from the hill slopes, soils which are important. These are called the on-site effects. So what happens at the slopes. And just to remind you that soils are a non-renewable resource. So it takes a long time when we lose the soil to get them back in places. The other thing to remind is that what we are losing is the top of the soil. And that's the part of the soil which is in general the best part. It's the most nutrient-rich part, has organic matter and so forth. What we also losing are the ashes and charcoal that is produced in the fire, and they represent a nutrient pool, as is a common agricultural practice. So we are also losing nutrients that are essential to the ecosystem. And when we lose soil on the hill slope, we also mean that we lose soil functions. Not to forget, soil have very important functions and provide ecosystem services, like it's a medium for growing of plants, it's a filtering zone, it's important for soil biodiversity, and so forth and so on. So losing soil on the hill slopes means this kind of impacts in terms of soil and soil land use sustainability. The other thing is that, like I showed on the videos, the material that we lose from the soils goes somewhere. So we also have at the same time fire enhanced risk of strong to extreme runoff responses in terms of streams. Together with the transport of water, we also have debris like big stones, sediment, ashes, nutrients, and also contaminants. These are the so-called offside effects. So offside impacts of soil erosion. So we need to consider both of them. And when we think about offside impacts, you can think about road safety. Like here's a picture where because of post-fire erosion, lots of stones are on the road. And if you're not careful driving, this can cause accidents. Well, already was shown by Aveiro, the big accident in 2006 in Galicia, where water was contaminated and we had big economic impacts in terms of agriculture. And of course, the occurrence of flooding. One news item from Portugal in 2017, that was basically 1 month after the fire in June. So very, very soon after, speaking about timing, right? The other picture is from Aveiro fire that we had last summer in Greece. Also within 1.5 months, they had a very big flood event, rainfall event. Okay, so now we know why we should assess soil erosion risk. The question is, how can we do it? There are different approaches to assessing the risk of post-fire erosion. And when I speak about risk, this is the possibility of it occurring. It's not measuring it after it occurred. That's a very different thing, okay? So what we can do if we want to know post-fire soil erosion risk, we can look to historical information. For example, in many cases, there are flood events in certain catchments. They are registered by civil protection. And if we have this kind of events without fire, we are for sure that we will have much bigger risks after the fire, or the chance at least exists. The other thing is we can look to the area and see if there are features of erosion that occur before the fire, because if they occur without fire, they are certainly in a risk of being bigger afterwards. Then we can use statistical models. Then we can use mathematical models. I will say more about that. And then we can also do something which is repeated surveying of post-fire erosion features. In this case, what we are doing is that we look at erosion features that occur after the fire. So we are actually not assessing the risk directly, but we are assessing the occurrence of erosion. And we can do the same by monitoring erosion, like Aveiro showed, with plots and so forth and so on. The question here is that we are using the occurrence of erosion to say the risk of having more erosion can be derived from those features. And those features can be observations by people, but they can also be derived from imagery, from drones, and so forth and so on. In EPyRIS, like Aveiro already said, we basically focused on these two types of models, the statistical models and the mathematical models. Okay, just to go a little bit back to the question of the post-fire erosion features. So if you have a burned area and you visit the area after a rainfall event, you can sometimes observe erosion features that give you an indication that there will be a higher risk afterwards. So there are here two pictures at this very small scale, the slope scale. You can see on the left picture, blacker and lighter colors. And this has to do with the fact that water has been running and has been removing the charcoal and ashes on that side. In this case, to quite high depth. So you can say erosion happened here after the first few events. There will be more erosion in the future. So there we want to do some intervention afterwards. But of course, we already had soil erosion, so it's not the ideal method. On the right picture, you can see sedimentation of ashes and charcoal that had been transported and are deposited in the area. So that's also an idea, is that the offside effects can be observed in this way if you go after events and find features that link to the post-fire erosion. Another picture that I want to show here that we observed last week, Antonio and me, was a picture of Antonio, where you can see in a burnt area, very profound erosion features, rills and gullies that have a certain dimension and are a very strong indicator for that you will have problems, more problems in the future. So you can use them to say, okay, I already have some erosion, but probably I get more, and so I'm going to treat the areas. Okay. Well, now back to the modeling. So that's the, let's say, the focus for the EPyRIS tool. We have the statistical model, like Alvar already said, that was developed by Cristina and Jose Antonio from the Lorenzano Research Institute. And basically what they do is they estimate the risk of post-fire erosion over the first year based on an equation in which soil burn severity is a key factor, rainfall is a key factor, and land use is a key factor. So basically the things we understand are relevant. Now, this kind of statistical models are very interesting, but you have to understand that they involve a lot of work from Cristina and colleagues. 65 plot year data. That means they had 65 places where they measure erosion during 1 year, in this case, in 10 fires. You can imagine this is a huge amount of work. So before you have a statistical model that works for your place, you need to invest a lot of time in data collection. So these kind of models are very useful when you have a lot of data, but they are maybe less useful in other places, and they definitely need to be validated by additional variations. And so that's why people use mathematical models. They are basically models that are more conceptual, and they are more based on trying to understand which factors are relevant and how they are relevant. And so for the EPyRIS, our team make a kind of a report on what is the state of affairs in terms of using mathematical models for the Sud-Aveiro region. So we did basically a review of the existing studies, and our conclusions were basically, and they led into the further development of the EPyRIS tool. We said that at this moment, the state of knowledge allows us to estimate post-fire erosion risk at the slope scale, but not at the catchment scale. That's much more difficult. There are much fewer data and so forth. We are not able to make robust, reliable estimations of the risk at this stage. When we talk about slope scale erosion risk, 4 models have been used: Guzle, Morgan, Finlay, Keizer, and Webb, which is an American model as well. But from the literature studies we have, there's no clearly one that performs much better than the other. So we can consider all 4 of them for the EPyRIS tool. But then taking into account the available data, because you can have a great model, but if you don't have map information that covers your region, they are not very useful. And in this case, we decided that MMF and Guzle were the best models because the data input that we need are more or less available for the Sud-Aveiro territory. Okay. Then actually we extended on this report and doing an analysis for, let's say, the whole world in terms of erosion risk modeling. And this was done in collaboration with the national project FEM, which is now being led by Antonio in the corner. It's a state of science paper, which means that basically we give a updated view on what's the current knowledge and the state of knowledge. And what I want to bring here are the 2 major conclusions of this paper, is that only a very limited amount of the studies that are published actually do a validation of model with independent data. I won't explain in detail, but basically this says that the robustness and the reliability of the predictions is more or less. There are clearly a lack of data. Yeah, lack of data to have a full, complete evaluation of the model. The other conclusion that we had is that also a reduced number of studies actually do an effort to adapt the models to burn conditions. For this, I have to explain that most of the erosion models come from agricultural lands, where the biggest problems occur in terms of erosion, not in forest lands. So most models come from that, have that background. And so to adjust them to burned areas requires that you think about what changes, what is different in a burned area compared with agricultural area, in terms of processes, in terms of parameters, and so forth. Just to say that modeling, let's say mathematical modeling, is possible, but still has a lot of difficulties. It's not like we are totally confident that all the results can be applied without an additional validation. Okay, like Alvaro also said, we basically selected two models, Roesle, which is a revised universal soil loss equation, which is an empirical model, which is based also on a lot of data, but there is a concept behind the model, and the model says like this: the annual soil erosion, A, is a function of a multiplication of 1, 2, 3, 4, 5, 6 factors, okay? And those factors are rainfall. Without rainfall, no erosion. Soil erodibility, so the soil, which is more prone to be transported and detached, is of course also a key factor. The other thing is, if you have a flat terrain, you have no erosion. So slope lengths and slope steepness terrain play also a role. And we also know that cover management, so the amount of cover we have over the soil, is also a key factor because they protect the soil. And there's another measure which has to do with supporting practices like plowing and so forth, that you can change the microtopography. But just to say that this is a model which has conceptually makes sense because all the key factors are there, but it doesn't represent processes. It just represents a multiplication of factors. Okay, it's a relatively simple model, and it's easy to apply. Then, like Alvaro also said, we also selected the Morgan-Finlay model. It's a little bit a more complex model because it's semi-empirical. It already has a kind of a view on which are the processes that we want to represent and how we can represent them. In this case, it represents, let's say, a sediment phase, which means how soil is being transported, and the other is how water is being generated that runs off and can actually transport the sediment. So that's a little bit a more complicated model. And like Alvaro already showed, I'm not going to explain this, of course, but just to give you an idea that a series of comparisons are being done, and that decides then on the total estimate. Okay, what am I? Okay, this scheme comes from a recent paper from our team. Actually, it was published yesterday or the day before yesterday, and this paper is about the application of the MMF model at the scale of Portugal to have a post-fire soil erosion risk map for entire Portugal. Okay. And this was, again, a collaboration between FEM and EPyRIS. So here you have the map. I'm also not going to dwell on it because also the paper is freely available for everybody on the internet. It's an open access paper also to make it available to anybody who's interested. I'm not going to give you any details. I just want to say that this map is based on a scenario, on the worst case scenario, in which it was selected a year with a lot of rainfall, so we have a higher risk because we have more rainfall, and also took into account soil burn severity or fire burn severity. In this case, 3 levels of severity: low, moderate, and high. And you can see in the table underneath that those 3 colors are recurring for different parameters and for different land covers. So basically what you do is that in function of the severity, you go to fetch for a certain land cover a certain value for a parameter. If the severity is 1, you take a certain value. If the severity is other, you take another value. So in that way, you can calibrate the model. Okay. What I also want to say in relation to this, and this comes back to what I said about the reliability of modeling, this map is interesting from the point of view that it's not just an application of a model to data that come from big data sources, from existing maps, but there is a validation of the model through field observations. Okay, so it's not just a model application, there's a validation. At the same time, draw your attention to the fact that the data that are available for validation are only for a part of Portugal, for the center and for the north. So here also we are missing data that we need to validate if the model also works very well for other regions. Okay. So now I want to give you some examples of the work we did in EPyRIS in terms of comparing these models, in this case, in burnt areas in Portugal. In this case, Loriga, a fire very small of 220 hectares. And we can see here the two maps of the models, soil erosion risk that of the first year by MMF and by Roesler on the right side. And then you have on the right side, you have a legend for the values in terms of tons per hectare per year. Okay, and so if you look at the values, those values are basically the same for the two models, 53 to 83. And you can also see the patterns in terms of red and yellow. And so they are more or less the same. So you have an idea that, okay, comparing the two models who are different, we get similar results. And this gives you more confidence in let's say, in that this assessment is useful. Just to say, like was also said before, fire severity is the key input for this, also derived from the EPyRIS tool that the colleagues will speak about a little bit later. The other thing, what I want to say is that we, during the EPyRIS project, we put in some erosion plots. We measure erosion to make sure that we can validate if the prediction of the model more or less is in agreement with our observations. Okay. Now is a picture from or a map from another area that burned in 2020. This was already a big burned area. And now if we look again to the values of the two models, we can see that MMF give much lower values than Roesler in terms of maximum values. This is maybe not such a problem, because if you look to the maps in terms of pattern of red and yellow and so forth, you can see there's quite a good incidence between the two models. So this is then very useful to say, okay, let me go to see those areas to see if there's really a risk or not. Okay. Again, we did some work here in terms of measuring erosion. Now at the scale of swales, I will show you. Do I still have time? Can continue talking? 5 minutes. Okay. I need to speed up. Another example from Custom Marine, a fire that was in 2001. And here, the difference between the models are very, very big. But again, we have a good coincidence in terms of spatial patterns, which allow us to do a validation. Okay. We did here a very quick erosion feature survey for an assessment. So if I have 5 minutes?
You have 5 minutes.
Okay. 15 minutes. I joke. Okay, good. So I'm going now back to the next question. I will cut it a little bit short. The thing is, why would you worry about identifying areas where you have a high soil erosion risk if you cannot do anything about it, if you cannot manage it, right? So this is the second question. We have now a map. What can we do with this map? Yeah, and so the question is, can we actually mitigate the risk of soil erosion? Can we actually do that? And the thing is, yes, we can, because lots of work has been done in the United States and in Galicia, in which people, through a lot of observation in the field, said, yeah, we can apply a series of techniques that are useful. And what the key here is, again, the treatment is done at the slopes and not in the streams, where the problem is already too serious to handle. Yeah. So yes, treat the hill slopes. No, don't treat the streams. Okay. I'm going to be a little bit faster now. In terms of the treatment, this report is also available. You can make a distinction between, let's say, treatments that are focusing on putting back a cover very quickly by seeds or by applying residues, changing something about the water quality, I won't say about that, or to create barriers where the water and the sediments are being stopped and held. The thing is that seeding and mulching, you can easily apply over a whole slope. You protect the soil everywhere. If you put barriers, you only protect, let's say, you don't protect the soil. Between the barriers, nothing happened. Soil is still being eroded. It just doesn't leave the hill slope. That's the difference. Okay, so just to say, this was there are reports. We recently did a review and a quantitative assessment of how effective those different treatments are all over the world. We did this together with people also from the United States and of course with Christina. 34 publications in journals, 39 study sites, much more data on erosion than of runoff. Runoff measurements are very difficult and always based on a comparison between doing something and not doing something, okay? So if you look at the study sites, the studies that are done in this field of erosion mitigation, you can see lots of work is done in the United States, in the western part. Lots of work is done in Galicia, and some work is done in Portugal, like I also showed on the previous map. Okay. In terms of results, this is the way you have to look at the graph. When you have a negative effect in meta-analysis, that means that the technique works. It reduces soil erosion. If you have a positive effect, don't use it because it actually increases erosion. Okay, so if we look at the results from these studies all over the world, comparing the different techniques, what we can see is the effect size. So the effectiveness is good. All the treatments do something, reduce erosion. But at the same time, we have differences between treatments that are based on cover and based on chemical. The chemical ones are not as good. At the same time, also the ones based on barriers and seeding are not as good as mulching. And one of the things is that you have to see, it's not only a question of that they are in average better, but they are also much more reliable because, for example, you can see in the barriers, the stripe is very broad. That means that sometimes they work okay and sometimes they don't work okay. So if you apply a technique which is not so reliable, you of course run a risk that is maybe you don't want. Just to say that these results from this quantitative analysis of all those studies published is very similar to what was already in the report from the Galicians. Basically, they are saying here the same. If you have little rainfall, all the techniques work more or less. The seeding not and the chemical not. If you have lots of rainfall, forget about it. The only thing that works is mulching, and mulching with straw and mulching with forest residues. Don't use hydromulching, okay? Another results that I would like to show is this one, in which we compare the different type of mulch that you can use. Wood mulch, hydromulch, and straw mulch. And you can see hydromulch is much less efficient, and much more expensive. So it's not a good option to use it, okay? Another results, very interesting. Of course, how much do you need to apply? What is the good quantity to apply? You always want to apply as little as possible. So here a study on the effectiveness of straw mulch, yeah? You can see if you apply very little, less than 200 grams, it's not so effective than if you apply 200 to 250 grams. But if you apply more than 250 grams, the results are the same. So basically, in terms of cost effectiveness, this is the best solution in this range. And this is shown from studies all over the world. So this is quite a robust assessment, okay? I'm going to skip this. Just to say that we are still working on implementing in the modeling, let's say, the effectiveness of scenarios. So now we have the risk, these maps of erosion risk. And what we actually would like to do is to make maps for if we apply these measures here at this time. And so what's the reduction in erosion risk? So and the scenarios that managers can consider. And we are still working on this based on literature, studies that were already published, in which we show that various models can be adjusted quite easily to get a good estimate of the reduction in erosion risk by the treatments, okay? Well, I'm not going to show this, just to show that this is the type of work you do with erosion plots, where you apply the treatments, and then you measure the erosion, and if you're lucky, ECNF helps you to provide the materials and so forth and so on. And basically, another study that we are doing in the framework of EPyRIS is looking to the catchment scale and not anymore at the plot scale, where we applied the application of barriers, which is something I just said I was against, but sometimes is the best solution. In this case, for example, because we were in a catchment where everything was terraced, so you don't expect a lot of erosion there. And why treat something where there's no erosion? So in this case, we put barriers. And just for you to show that it actually works, because we have, you can see the barrier is there in wood, and on the right-hand side, you see accumulation of charcoal and ashes and so forth. So they actually work quite well. I'm finishing, yes. 3 messages that I would like you to keep in mind. If you do mulching, yeah, very effective method to reduce erosion risk, and you can protect the soil over the entire hill slope. So you are not putting in risk soil land use sustainability for the whole field, let's say. The other thing, it has been said many times, timing is essential. If you do it before the first rainfall event, you have maximum effectiveness. If you do it 1 year later, you already lost a lot of soil, and so your effectiveness goes down quite considerably. And the other thing, maybe because I'm a scientist, but I think the work by Lorisan has shown this, you need to monitor. If you do something, please measure, because you want to show if it actually worked on the place that you applied it to. The second thing is you want to learn about errors that you make when you're applying. There is a famous example from the United States where they applied straw modes by helicopter and it still gave a lot of erosion. That was the video I was showing you with the big boulders. The thing was they applied straw, there was wind, and by the time the rain came, there was no straw. So they learned from this. They actually learned from that. And the other thing is that it's very important to have this data to improve modeling capacities in the future so that we can make better erosion risk maps and better maps of what are the consequences and implication advantages of measures that we take. Thank you very much. And some pictures of the people going to the field collecting data.
Gracias, Jan.